Pushpendra sir. Pushpendra, can you hear us?
Yes.
Okay. So we are going to start.
Yes. Okay.
Good afternoon, sir.
Good afternoon.
Good afternoon, one and all present here. I, Dr. Gaurav Raj, on behalf of Sharda University, welcome you all in 8th keynote session under 4th 1-week International FDP, themed on recent advances in computer science and allied domain. I hope you have enjoyed the sessions delivered so far. Today we are having with us Dr. Pushpendukar, Assistant Professor, University of Nottingham, UK. Before this, he was a research fellow in the Department of ICT and Natural Science at Norwegian University of Science and Technology, Norway, the Department of Electrical and Computer Engineering at NUS, and Energy Research Institute at Nanyang Technical University, Singapore. He has completed all his PhD, Master's in Engineering, Bachelor in Technology in Computer Science and Engineering domain. He also completed Sun Certified Java Programmer, SCJP 5.0. Dr. Kerr went for research visit to Paris, France. Dr. Kerr was awarded the prestigious postdoctoral fellowship, Erasmus Mundus Postdoctoral Fellowship of European Commission, ERCIM Eliam Bensoson Fellowship of European Union, and Sir OPD Fellowship of Department of Science and Technology, Government of India. He received the 2020 IEEE System Journal Best Paper Award also. Dr. Kerr is a IEEE senior member. He also received several travel grants to attend conferences and doctoral colloquiums. Dr. Kerr has more than 12 years of teaching and research experience. He worked as a software professional in IBM for 1.5 years. Dr. Kerr is as author of more than 37 scholarly research articles, which has been published in reputed journals including ACM, TAAS, IEEE, TNSM, IEEE System Journals, IEEE Sensor Journals, Journal of Building and Environments, conferences including ICC, TenCon, IECon, and IT magazines. He is also an inventor of 4 patents. He has participated in the program committee of several conferences, worked as a team member of organized short-term courses, and delivered a number of invited talks. He is regular reviewer of IEEE, Elsevier, Wiley, and Springer journals and conferences. With these words, may I now request Dr. Pushpendukar to take over and address the gatherings. Welcome, sir.
Thank you, Dr. Gaurav, for giving the nice introduction. And thank you to the Sharda University for inviting me for a keynote talk in the faculty development programming. So here in this talk, I will present one of my research work, that is the name signature lookup system for enhanced security of Indian-based IoT network. Is my slide visible? Let me share my screen. My slides are visible now.
So it's loading.
Okay.
Yes, sir, it's visible.
Visible now?
Yes, yes.
Yes, sir.
Okay. Okay. So, okay. So I will present one of my research work named signature lookup system for enhanced security of Indian-based IoT network. So here, the most two bold words you are finding from the title, that is the Indian and name signature lookup system. So before going further, before discussing in more detail about the name signature lookup system, we need to first understand what is NDN. NDN is the name data networking. This is the outline of my presentation. First, I will introduce the NDN and what is NDN and what is the NDN technology. Then I will introduce the drawback of the current internet. Then I will discuss why NDN is required, why NDN came. Then I will discuss NDN data structure, then NDN architecture, then NDN benefits of NDN. Then I will discuss the current security issues of NDN, name data network. Then I will discuss our proposed name signature lookup system. Then I will conclude my presentation. In introduction, I will tell that thought of internet started as early as 1960. In 1960, the thought of internet has started. The internet, the idea of internet has came in reality in 1960. That it basically came as a project named ARPANET by the US Department of Defense, initiated a project called ARPANET. And by this project, the internet, the concept of internet, idea of internet came into reality. The first message sent over the ARPANET in 1969. In 1991, World Wide Web, that is the WWW concept introduced in internet. And that is a revolutionized concept which basically drastically change the internet and make it popular among the common people. World Wide Web. Throughout the time, internet showed potential to exchange data between user. User means client. Here in the internet architecture, the user, the end user, like us, is called as the client. Client means we have the devices through which we are getting some data over the internet. And the data sources are the server. Server basically hosts all the data. The client devices like our mobile phone, laptops, computers, all these kind of client devices access data over the internet. Okay, and it works on IP-based network. It basically works. This internet works on the IP-based network. Here in this network, each devices, the end devices, intermediate devices, as well as the server having a address, an IP address. So we all know, most of us know the what is IP address. So I am not going details about that IP address. So each and every devices in the internet having an IP address. So what is the drawbacks of the current internet? What are the drawbacks of the current internet? Most of the recent applications are content centric. If you think, if you see the recent applications starting from the YouTube, Facebook, any other applications, or mostly depend on the data. They basically deal with the data. They basically exchange the data between the client device and the server. But where data is hosted, on which server, on which country that server is located, that is not important at all. We are mostly interested about the data, to get some data. When you are accessing the Facebook pages, when you are watching the YouTube videos, do you know from which server this data is coming to you? Where is that server is located? We do not know that. We even don't bother about that. So most of the recent applications running online mostly depend on data. That is the content centric, not location centric. Current internet is lacking to adopt the content-based data distribution model because of its design. Because the current internet has designed based on specific IP address. Each and every device is having IP addresses. So when you are accessing the data, the IP address of the location also getting associated with the data. So you are basically that location of the data also matters in the current internet. But location is not so important nowadays. People are mostly bothered. People are mostly interested about the data, what data they want to access. Most of the application data delivery model rely on content instead of location of the data. We are not bothered about the location, from where data is coming from, which server it is coming from. We are bothered about the data, we are bothered about which video we want to watch on YouTube, which post we want to see on the Facebook. We are bothered about that. But from where, which computer, which server, which location, that data, that post, that video is coming from, we are not at all interested. Content is getting popularity than location. So content of the data is getting popularity than location, from where data is coming from. Physical location of data such as IP address is getting obsolete. So IP address is getting obsolete. IP address basically represent the location of the data, represent the address of the server, of the devices. So when IP address getting obsolete, and we are mostly depending on the content of the things, of the items what we are accessing over the internet, then IP address losing its meaning, its significance. So scarcity of IP address has become added with it. We know that IPv4 addresses become scarce. Nowadays, people are using thousands, millions, and trillions of devices. They are connecting over the internet. So IP address, each and every devices need to assign an IP address, unique IP address. The IPv4 address now become very scarce, becomes scarcity. And it is become difficult to assign a unique address to each and every devices connecting over the internet in IPv4 addressing framework. So people are thinking about to shift to the IPv6 addressing framework, but still the IPv6 having some limitations. We cannot assign, if the number of devices increase rapidly like this, what is like the current trend, then the in future the IPv6 address also become in scarcity. Mobility, so this scarcity of the IP address also added a difficulty with the current internet system, internet architecture. As well as the mobility and security issue are handled by add-ons which may not be always reliable. If you minutely watch in the current internet, if you minutely study the current internet architecture, then you can see that mobility and security issues and options are provided to the current internet with the help of add-ons. Means adding some by giving some additional support to the current internet. Current internet cannot inherently manage mobility and security issues. We need to provide some additional support to the current internet to manage this kind of issues. So the necessity of the content-centric network has arisen. So now people have started to think on to introduce a new kind of network technique, that is the network technique where the content will be given more priority instead of the location. The networking will be performed based on data content instead of the location, where content will be given more importance than the location of the data. Okay, so why the way to name data networking? NDN. NDN is the full form of NDN is the sort of named data networking. So NDN makes the user capable to exchange data without knowing their location. So named data networking basically makes user capable, giving the user ability or allow the user to exchange data without knowing their location, from where data is where data is located, from where they are accessing data. All this information do not need to know by the users. It can easily adopt content-centric data delivery model. So if the users need not to bother about the location of the data, so they can easily, the Indian architecture can easily adopt the content-centric data delivery model instead of location-centric, that is the IP-based data delivery model. They do not depend on IP address. They need not to depend IP address. And it can strive through scarcity of IP address. Though there is scarcity of the IP address, it can easily survive that situation. Indian can handle mobility and security issues inherently. Indian can handle mobility and security issues inherently and more efficiently than current internet. Because in the current internet, we know we are all using mobile devices, our mobile phone, laptop, tablet, PC. We basically carry all these devices with us. The end devices, most of the end devices nowadays over the internet are mobile devices. But current internet cannot handle the mobility and security issues inherently. They need to be handled by add-ons, additional support. But so that is the major drawback of the current internet. But Indian named data networking can handle mobility and security issues inherently, okay, and more efficiently than the current internet. So these are the hourglass architecture stack of the current IP-based network and the Indian network. On the left-hand side, in this left-hand side, you can see the hourglass architecture of the current internet. It is very well known. And I think most of us know this hourglass architecture. But this right-hand side is the Indian architecture, the different layers of Indian. So here you can see that IP layer has been replaced by named data layer. In the named data networking Indian architecture, the IP layer has been replaced by the named data layer. So more or less other layers are near similar with the IP-based layers, but the most changes has been happened in this layer, in the IP layer, which has been replaced by the named data layer. The named data structure in the Indian named data networking, named data networking basically use three important data structures. First one is the content store. In short, it is called CS, content store. The cache, it basically cache store the data packet. D underscore packet means data packet to pass to the multiple users. Here in Indian architecture, Indian network, basically in network caching happens. In network caching means all the intermediate nodes over the network will hold a frequently used data by the users, by the clients in their memory, in their storage. If a user requests data which has been requested by the another client or another user earlier, or by the same user earlier, the data packet need not to be request, that is the interest of the data packet, need not to send the server, that is the source of the data packet, that is called producer. Here in Indian, the client is called as consumer and the server is called producer. So when consumer need a data packet, it need to send an interest message over the network. But interest message need to be forwarded to the intermediate node to the producer, that is the server. But here in the Indian network, each intermediate node cache the data packets for future use. If an user already requested the same data packet earlier, then his interest packet, the user's interest packet, need not to send again to the producer. The data packet will be derived from the intermediate cache, from the cache having inside the intermediate nodes. If the same data packet, the data packet for the same interest already stored in the cache of the intermediate nodes. Okay. There is another table is the pending interest table. Another important table, that is the pending interest table. In short, it is called PIT. So PIT basically maintains an entry for each incoming interest packet. I packet means interest packet. I packet is the interest packet. Interest packet means when a consumer, that is the client, need to access a data packet, they basically send the interest by interest packet. Send the request by interest packet, I packet. And the producer basically send the data, or the intermediate node send back the data in the form of data packet, DPKT. Okay. So PIT basically maintains entry for each incoming interest packet until its corresponding data packet arrives. The incoming PIT, pending interest table, basically maintain an entry. When a consumer sent an interest packet, if that corresponding data packet is not in the cache content store, then the PIT will store that, make an entry, that intermediate node make an entry in the PIT, pending interest table, for corresponding interest packet, and this entry will be removed from the PIT when the corresponding data packet arrives or the timeout happens. That the interest packet arrives to the intermediate node should wait for the corresponding data packet for some time. If the timeout happens, the interest packet will be expired and deleted from the pending interest table. Then another significant table, data structure, Indian uses, that is the forwarding information base, FIB. FIB basically kind of a routing table in the current internet architecture. FIB basically holds the maintains the next hop and other information for each reachable destination name prefix. FIB basically basically store all the reachable destination names and their prefix and interfaces of the reachable destinations. And if there is a matching with the name prefix stored in the FIB, then the packet will be forwarded the corresponding interface in the forwarding information FIB table. So this table basically is kind of similar to the routing table of the current internet architecture. So these are the three most important data structures and uses by the Indian named data network. This is the pictorial representation of the data structure. This is called content store. It basically stores the content in the form of content name, that is the interest name, packet name, and the data of the corresponding packet. The data having in that packet. Okay. And PIT basically also holds the interest name, that the packet name, and the interface. 0 or on, it is kind of interface. It holds the value 0 means in the packet is present. Packet can be this interest message, sent by the consumer is currently active or not active. Forwarding information base basically hold the name prefix and the interface, and that is the kind of which interface the packet should be forwarded to reach to the destination. Okay, these are the three data structure used in the basically store in the each and every intermediate router of the named data networking architecture. This is the working principle, the way of working in a Indian router. This flow diagram basically presents how each and every Indian routers works. Here you can see that the solid rectangle means exact matching, and dotted rectangle means longest prefix matching. Here solid line means matched, and dotted arrow means miss. That is the do not match. First, the interest packet will be arrived to this intermediate node, and that is the interest packet is arriving from the consumer to this intermediate node. That is the I packet arrives to this node, and it will first, when interest packet arrives to this node, first it will check inside the content store. If the content store holding the similar packet, same packet with the same name, hold the packet with the same name, then that packet will be returned to that consumer. If the content store do not hold the packet with the same name, then there is a mismatch. That is the mismatch. Then an entry will be added, pending interest table, in the pending interest table with the packet name, interest packet name, and the request will be forwarded to the FIB. Okay. First, it will search to the pending interest table. If there is a matching in the pending interest table, means this interest packet already reach to this intermediate node, and that is still alive, active. Then this request will be dropped out. Otherwise, if there is a miss, an entry will be added in the pending interest table, create a PIT entry, and the request will be forwarded to the FIB. In the FIB, basically longest prefix match will happen in the FIB. Longest, the name will be name of the name basically stored in the FIB, name of the packets stored in the FIB in the form of URLs. That's the hierarchical structure. So there in the FIB, the matching will be performed as a longest prefix match. And if there is a longest prefix match happens, the packet will be forwarded, the interest packet will be forwarded to this interface, according to the interface which is matching with the longest prefix stored in the FIB. If there is no longest prefix match, there is a mismatch, then the interest packet will be dropped. So the packet cannot be reached to the destination, and that packet cannot be delivered. Corresponding data packet cannot be delivered. If the interest packet moves towards the destination and reach to the destination, then the corresponding data packet will be moved back in the downstream path, following the upstream path of the interest packet, I packet. The data packet will follow the downstream path of the upstream path of interest packet, I packet. So when the data packet arrives to this intermediate node, it will first check the pending interest table, PIT table. If the corresponding interest, the packet name, interest entry in the pending interest table still alive, then it will delete the PIT entry and send back the data to the consumer. Send the data to the consumer, and a copy of the data will be stored in the content store for future reference, for future purpose. If the same data packet is requested by the consumer again or other consumer again, then it will be forwarded. It will be sent from the content store again. The interest need not to be forwarded to the producer again, and it will be fast. The propagation, it will reduce the propagation delay. If the corresponding PIT entry for that data packet has been deleted or timeout, the data packet will be dropped there on that node. So this is the overall working principle of each and every intermediate nodes, that is the Indian router over an Indian network. Okay, so I told that Indian supports mobility and security inherently. So how Indian supports mobility and security inherently? Indian supports data access by content names. What we see, instead of IP address, Indian name data network basically support data access by content name instead of IP address, which enables the mobile users to have better data access, as there is no need for them to repeatedly acquire IP address. You know, those who work on the mobile network, they may know that when a mobile device moves from one access point, from a range of the one access point to the another access point, then going to the another access, after going to the another access point, the mobile device need to get a new IP address, new address in the new location, and need to register themselves, the mobile device itself, to the new location with the new address. So when a device is moving from one access point to another access point, every time they need to get new address, new IP address and register to the new location. And that basically makes difficult for the current internet to handle mobility. And there are a lot of issue arrives in this kind of mobility, in this kind of mobile network in the current internet. But in Indian, there is no concept of the IP address. So concept of IP address has been removed by the content name. So they basically use the content name instead of location. So when a device, mobile device, moving from one access point to the another access point, going to the new access point, they need not to achieve, did not to get the IP address to be registered with the new location. So mobility can be inherently support in the Indian network instead of current internet. Indian uses the content encryption to support access control and confidentiality. Indian basically use the content, each data packet in over the Indian network remains encrypted. So the we need not to here in the current internet what happens, there is data packet do not remain encrypted. We basically encrypt the channel with some kind of support, with some kind of additional algorithms, additional add-ons. We make the channel between the client and server encrypted, secure by additional support. And over the channel, we basically send the data packets. But in Indian, all the data packets remain encrypted. So we need not to verify the data packet by some kind of trusted server or trusted directories. So we need not to implement any strict access control policy over the Indian instead the current IP network. Okay, this is the two advantages, and this two advantages of the Indian is supported in the Indian network inherently, not by any kind of external support add-ons. But though the Indian support security issue inherently, still the current Indian architecture having some security issues. Like Indian deals directly with content names, directly with the content names. So the content property remain available explicitly. The content name in the Indian, the name of the content, each content, it is not remain encrypted over the Indian. So content name remain available to the external person or external entity. That is another advantage, security issue of Indian. There is no defined policy for key creation, distribution, and revocation in current internet Indian. In the current Indian, there is no defined policy for key creation, distribution, and revocation. Access control mechanisms are not well defined. Access control mechanisms over the Indian is not well defined. Attackers may track users' information by monitoring their content request. Attacker can track the user information by monitoring their content request, how they are sending the content request, because they can see the content request from the content names. So they can easily track how they are requesting the content. They can see the user's trend of accessing the information over the Indian network. And this way they can guess, or they can track the user information. So these are the possible security issues of the current Indian network. So for solving these security issues, we have proposed a new security solution for the Indian network called name signature lookup system, which basically makes the current Indian network more secure to deal with the extreme attacks like the man in the middle attack. Actually, man in the middle attack. What is man in the middle attack? It is a very extreme kind of attack on the networks, in the IP network as well as the Indian networks can happen. So our name signature lookup system basically designed to deal this type of attacks called man in the middle attack. In the man in the middle attack, basically a malicious node can block the consumer and keep intercepting the interest packet sent out so as to fake the corresponding data packet signed with its own private key. Manage the middle attack means when a new consumer newly connects to an Indian network, then its identity, the current Indian network cannot verify its identity. So when a consumer newly joined an Indian network, newly connected with an Indian network, during that time, if another malicious node just misrepresent the newly joined consumer as a authentic consumer to the network, then it can easily do so, and it can send the malicious interest packet to the other nodes to the network, and can send the malicious data packets to the other node over the network, and by this way it can corrupt all the nodes connected to the network. It can send the corrupted request interest packets as well as the corrupted data packet over the network, and can steal the data, private data of the users. So without the knowledge of the trust to the network, the Indian consumer can by no means perceive the attack. So the consumer, the newly joined consumer, just joined the network, they don't have any trust information over the network. So basically, he cannot verify its identity with the other nodes or with the security policy of the network. So Indian consumer, that newly joined Indian consumer, easily perceived by a malicious node, and that basically expose the server security and privacy hazards. So name signature lookup system, how it works? Name signature lookup system, NSLS, and the corresponding protocol. The protocol means the rule how the name signature protocol system will work. That is called name signature lookup protocol, NSLP. We introduced this name signature lookup system and corresponding protocol called name signature lookup protocol. It basically verifies packet with their registered genuine publisher, even in an untrusted network. If the a consumer join over the untrusted network, where the authenticity of the each node over the network has not been verified yet. So untrusted network, still after joining the over the untrusted network, the consumer's identity will be verified by a trusted server, registered genuine publisher. This technique uses the embedded key inside the network interface controller. For doing this, each of the devices over the Indian network should embed a private key in their network interface controller, NIC controller. That's an NIC card. In the NIC card, they will include a private key given by the trusted genuine publisher. This technique eliminates the attack like MITM, man in the middle attack. Okay, this is the basically diagram. This basically represents the name signature lookup systems. Here, the NSLS server generates a pair of RSA asymmetric key and make it accessible to all the manufacturers of NIC. NSLS server, here NSLS server basically this is the NSLS global, this is the NSLS server. Basically, what they create a RSA asymmetric cryptographic key, and distribute all the manufacturers of the devices, Indian devices, and to embed this key in the NIC, network interface card controller. To support a specific NSLS server of the NSLP, the manufacturer should embed up-to-date accessible public key to the NSLS server into the NIC. So each and every device want to participate that network, Indian network, they need to get the RSA asymmetric key from the NSLS server and need to embed that asymmetric key in the NIC, network interface card. The Indian consumers should equip their network accessing node with the NIC supporting NSLSP. All the Indian consumers, in their devices, they should install the NIC supporting NSLSP algorithms to participate in this kind of NDN network and ensure their security over the network. So this is the flow diagram. This is the system architecture diagram, how the name signature lookup system works. Here, this is basically NIC device. Sorry, NSLS is an Indian device. It basically sends data packet. It is a kind of consumer, Indian consumer. It basically sends a data packet pname and another data packet tagged with NSLS, NSLS/pname. When these two data packet goes proceed over the Indian network, and then the when it reaches to the NSLS server, the NSLS server basically verify the NSLS pname packet with the key, public key, encrypted public key stored inside the server, and the get the NSLS by the NSLS signature and get the pname dot public key. From that NSLS pname packet, it basically extract the public key, and by that public key, it basically verify the pname packet. This is the actual packet which basically stores the content. It basically by that pname public key extract out from the NSLS packet, it basically verify the actual packet having the content. And then when the content is verified, then it is authenticity is verified, then it is a genuine packet coming from the genuine source, genuine provider. So this packet can be easily accessed by the consumer. This is the algorithm for the name signature lookup system, basically name signature lookup protocol. Then here in this, this is the flow diagram. This is the flow diagram, and this is the these are the two algorithms. This is the name signature key generation algorithms, and this is the how the name signature name signature packet will be verified over the network. That process has been presented here in a form of algorithm. Okay, so we collected some data. We simulated our result. We simulated our name signature lookup protocol and name signature lookup system over the simulator, over the NS3 simulator, and we found some data. And from the data, from the this graph, that is the graph on the left hand side, we basically presented the data after analyzing the network performance when we encountered the 50% of the extreme MITM attacks. There is the among the all the data packets sent by the consumers or the producers, among them 50% are the malicious data packets that are sent by the attackers. So in that case, we can find that NSLP, that is the detection, the MITM packet detection has been increasing when the MITM packet with the fabricated signature sent. When the number of MITM packet has increased, the detection number of packet detection also increased more than the regular Indian network. So our NSLP system detected more MITM packets compared to the regular Indian networks. Here in this diagram, that's the plot on the right hand side, you can see that in this plot, the interest packet sent for a data packet and amount of hierarchical naming domain. That is the how many interest packet we need to send. That is the network overhead. How many interest packet we need to send over the network when the hierarchical naming domain increases or extends. Then from this result, you can see that in case of NDN, the number of interest packet increases rapidly compared to the NSLP. In case of NSLP, the number of interest packet is constant when there is the hierarchical domain name increases. If hierarchical domain name increases, still the number of interest packet in NSLP remains constant. but it increases rapidly in case of regular NDN. So what are the advantages of the name signature lookup system? The name signature lookup system provides three major advantage, that is the overhead, scalability, and compatibility. From this figure, if you can easily see that overhead of our NSLP on top of the regular NDN network is more better than the regular NDN. So use of NSLP on NDN, on top of NDN, basically improves the NDN performance compared to the regular NDN performance. Okay, and scalability is that when you can make any computer, any server as a to participate, or any device to participate over the network as a NSLP device, and to participate in the NSLP network, NSLS system with the if the device having that public key, RSA asymmetric key generated by the NSLP system. The compatibility is that this NSLP and the NSLS system easily compatible with the regular NDN. You can use this NSLP protocol and NSLS system on top of the regular NDN network, and regular NDN network can easily adopt this system. But still, this algorithm, this technique, having two space to improve. That is the protection to the private key in servers. That if the private key is the major concern to make the system secure. So if by some unethical person or some kind of unauthenticated person distribute or gives the private key to any malicious attackers, then the attacker can easily attack the network. Cooperation with the hardware manufacturers. If the hardware manufacturers, I can having a good friendship, a cooperation with the hardware manufacturer, and they share the public key which has been embedded in all the NIC of all the Indian devices, NSLS devices, then the NSLS system will break down. The attacker can easily attack the NSLS system and can send the malicious data over the network. So in conclusion, the NDN is becoming a promising networking technique in the era of data-centric communication. So data-centric communication now, networking are shifting, the notion of networking basically shifting from location-centric communication to the data-centric communication. So what I told in the introduction, our recent applications are mostly depend on data instead of the location. So NDN is becoming a promising networking technique. NDN has many benefits like multicast, in-network caching, intelligent and stateful forwarding, scalability, easy application development and deployment nature. But still, NDN has few security challenges due to undefined key distribution and access control policy. So our NSLS system, that's a name signature lookup system, basically uses a semantically centralized registry with hardware level support to prevent some kind of extreme attacks from the NDN network, that is called man-in-the-middle attacks. So I have used this. These are the few references I have followed to develop to build this research and develop this scheme protocol technique. Thank you. If you have any query, any question, you can ask me now, or you can send email to me later.
Thank you very much, sir. Definitely all the participants get the benefit from this wonderful presentation and get the knowledge about this name data network.
Thank you.
All the participants, if you are having any query or any doubt, you may ask your queries in the chat box. You may write your queries. I think
if you have any query, you can ask me here, or you can send email
chat.
Also later.
Yes. Sir, if it is possible, you please write your email address.
Yes, sure.
Chat box.
Yes.
One query is coming from Rani, that is how Indian is compatible with modern router.
If you want to adopt the Indian, then you need to change the whole networking architecture. The modern router, if the modern router cannot been developed, has not been developed to deal with Indian networking features, Indian networking concepts, then the modern router cannot deal that, cannot participate, cannot be used in the Indian network. So any router, any device want to participate over the Indian network, that device or router has been developed to deal or to be to deal with the Indian communication features, Indian communication techniques.
Means hardware level modification is required.
Hardware level modification or the software level modification, the communication architecture need to be built up on the routers. Indian communication architecture. What I saw in my presentation, that there is a different hourglass architecture for the Indian network, which is different from the IP-based network. So if you want that your router or your device want to participate in an Indian network, then your router or device need to implement that kind of techniques in the hardware level as well as in the networking protocol, networking stack on that device.
Miss Monica has asked another question. What is gray hole packet drop? If you can.
Gray hole packet drop.
Yes.
I don't have any knowledge about this.
Okay.
I need to look into it.
Okay. So one question from my end.
What
also,
I can tell that this gray hole packet drop.
Question. Yes, yes,
okay.
Sir. Please.
Gray hole packet drop is not specifically for Indian networks. It may be any kind of network. So we need to know that for which kind of network this kind of gray hole packet drop situation or packet drop issue can be arise. If it arises in the Indian network, then we need to think about in the concept of data centric communication, how this packet drop can be solved. Otherwise, if this packet drop can be arrived in the IP-based network, in the concept of the IP-based system, we need to modify or we need to think how to solve this kind of packet drop in the concept of IP-based communication.
How can we check this performance of NDN in trusted and untrusted network? And what is the possibility of improvement in access control of NDN?
Yeah, basically possibility of access control improvement, that NSLP, that is a NSLS, name signature lookup system, is a possible way of improvement of the some issues of the security issues of the current Indian network, as well as the we can also introduce an way technique to encrypt the content names over the network, because the one major problem of the current Indian network is that the content names remain exposed to the external entity. The external entity can easily access the content names still in the current Indian network. So we need to decide. We need to think about some policy or some techniques which can make the which will also encrypt the content names. Encrypt the content name so that the external entity cannot get the content names as a raw content name. They can get the content name in an encrypted format, and second, they cannot decrypt it. So that will basically improve the security of the current Indian network also. But so far, whatever work has been done for Indian network has not been considered the encryption of the content name. They basically tries to, there are many few issues having involved the encryption of the content names. So we need to think all this kind of issues and the possibility of encryption of the content name in Indian networks. So far, whatever the solution are available, all this solution basically has been done by use of separate trusted server, or kind of encrypting the data packet, or encrypting the interaction between the client, and that's the consumer, and the producer, by different kind of using different kind of encryption techniques. So these are the
kind of trust mechanism we can develop.
trusting mechanism. Yes, right. Trusting mechanism has been developed. So, but so far there are still some security issues on the Indian available. So these are the some research gaps, research issues available on the Indian network, current Indian network.
Thank you very much, sir, for your kind answers and solving the queries.
Okay.
We will definitely be in touch in future.
Okay.
I think no query from the
okay. So
participants.
I send my email address here. So if anyone
this
having
will be
query,
very helpful for the participant to contact.
Okay.
Thank you very much, sir.
Okay. So I am leaving from the meeting room.
Thank you very much. Thank you very much.
Welcome. Yeah. Bye.
Bye, sir. Dear participants, you can fill the feedback form. The link is already in the chat box. This will be active for next 5 minutes.
Gaurav sir, share the details of the tomorrow session also.
Yes, sir, yes. I'm sharing. Tomorrow we are having a session at 11 a.m. first session, and second session at 2 p.m. The details I will share you. (11 a.m. to 12:30), a keynote session is by Dr. Umpal Singh. This is from MIT, India. And the second session is from 2 to 3 p.m. This is keynote session from Dr. Ajit Tripathi, Senior Software Engineer of Microsoft. So we will expect all of you to be on time. Before 5 minutes will be expected to all of you to join. If you have any query, please contact me on WhatsApp. You can send personal messages. Thank you very much. Thank you very much from all of you.